Welcome to the deep dive. Today we're focusing on an environment where context is everything. We're talking about the massive, crucial world of logistics and warehouse operations.
Exactly. Because when you're trying to prevent serious accidents, waiting for that injury report to land on your desk,
You've already failed.
you've already failed.
Yeah.
And we see so much innovation in, supply chain speed, but safety innovation often lags.
Well, and the necessity is it's huge.
It's absolutely staggering. If you look at the UK, just for the transportation and storage sector between 2022 and 2023, there were 15 fatalities
15.
and a terrifying 29,000 non-fatal injuries.
Wow. And what about the U.S.?
In the U.S., the rate is stuck. It's around 220 non-fatal injuries for every 10,000 workers.
These are not numbers we can just, leave to the old manual reactive processes.
Not at all.
And that really gets to the core flaw in traditional safety reporting, doesn't it? It's almost always reactive.
Always.
A clipboard comes out after the fact, questions are asked, and the focus is only on the incident itself. The goods fell, the forklift tipped over.
Right, the catastrophic event.
No,
But it completely misses the critical context leading up to it.
the precursor events.
Exactly. It lacks that rich, minute-by-minute sequence of actions that create the risk in the first place. You miss the full chain of events.
And without that chain, you're essentially just guessing at the root cause. Right?
You are. You might identify the failure point, sure, but you don't get the why. You don't understand the operational decisions that allowed that failure to happen.
Which just delays any real safety improvements and lets the same things happen again.
And again.
So our mission today is to dive into a new system that promises to fix this. It's a really powerful integration of computer vision, CV, and large language models, or LLMs. And this tech automatically generates these comprehensive contextual safety reports by tracking the entire sequence of events, the chain of thought, before, during, and after an incident.
Yeah, and this approach has two sort of interlocking pieces. Okay. First, you've got the computer vision model. It's sophisticated, it actively monitors the environment, and it detects the whole flow of events.
And the second piece.
The second is that it feeds all that data into an LLM using a specialized technique. It's called chain of thought prompting, or CUT.
And that forces the AI to, what, think logically?
It forces it to compile an immediate, comprehensive, and logically sound report.
Okay, let's unpack this. We have to start with the eyes of the operation, the computer vision system. Now, they used real-world footage, right, from a company called Conway Packaging Services.
That's right.
How did they even begin to handle that sheer volume of video data?
Well, efficiency was key. I mean, you can't analyze every single frame. It's just too computationally expensive, way too slow.
Right.
So they came up with a clever compromise. The system processes every 100th frame.
Ah, okay. So you're getting a snapshot.
You're getting enough visual information to track movement and changes, but you've massively reduced the computational load.
Yeah.
It keeps the system fast enough to be useful in real time.
And to make sure that timeline is absolutely solid, they use something called OCR.
Precisely. To reconstruct the timeline accurately, you need to know exactly when something happened. So they use optical character recognition, specifically a tool called Easy OCR, to pull the exact date and timestamp, the T, directly from the video frame itself.
So it's not based on the computer's clock, it's based on the source video.
Exactly. It provides an undeniable anchor for the whole event sequence.
Now let's get to the core of the CV, the detection. When we think of AI safety, we usually think of it just identifying objects, forklift, pallet.
Yeah, simple labels.
But here, they're identifying events. What kind of event detectors did they test?
They pitted three really high-performance models against each other. YOLOv11, YOLOv11, and the more established Faster R-CNN.
And the crucial difference is what they were trained on.
Right. They were trained specifically on human actions and interactions with the machinery. So the system isn't just seeing a forklift.
It's seeing forklift moving towards the truck.
Or forklift lifting goods. And critically, the main event. Goods fell from the forklift carrying it incident. This is absolutely essential for capturing that sequence.
So who came out on top? Who was the best at seeing and labeling these events?
YOLOv11. It was the clear winner, just superior performance across the board.
Let's talk numbers, because in safety, these metrics really matter. It's not just that it's accurate, it's how it's accurate, especially when we're dealing with human life.
Absolutely. So YOLOv11 achieved a precision of 0.806. That means when it said an incident was happening, it was usually right.
Okay.
But more critically for safety, its recall was 0.955.
And high recall is what you want.
It's paramount. It means the system is missing very few true incidents. You want minimal false negatives. You just You cannot afford to miss an accident that actually happened.
And what about its other scores?
Its mean average precision, the MAP50 score, hit an impressive 0.972.
Wow.
Yeah, it confirms its ability to accurately localize and classify those events over and over again.
That sounds almost perfect.
Oh.
But the research notes a surprising little quirk. Even with that incredible accuracy, the visual data could sometimes come back a bit jumbled.
Yes. And this is a really critical nuance. The visual models, they're driven by high frame rates. There's processing lag.
Right.
So they would occasionally detect and timestamp events slightly out of their true causal order.
Give me an example.
Okay, so YOLOv11 might detect personnel inspecting the damage a millisecond before it detects the goods actually falling.
Wait, really?
Or it might timestamp the forklift moving away from the truck before it timestamps the approach.
Hold on a minute. If the raw visual data has flawed timing, even if it's dead-on accurate about what happened, isn't that a massive vulnerability?
It could be.
If you're going to automate reporting based on context, that context has to be in the right order. How do you fix fundamentally jumbled timestamps with text processing?
And that is the exact point where the LLM becomes the logical editor.
I see.
The visual models deliver the accurate ingredients, event A, event B, event C, with their rough timestamps, but they might deliver them in the order CAD.
And that imperfection is where the language model has to step in.
It's where the necessity of the language model to enforce logical causality comes from.
Okay, so we're moving from just seeing to reasoning. This is where the magic of chain of thought prompting comes into play in Section 2.
Exactly. If you just feed a traditional LLM a messy list of raw data, it often struggles with complex reasoning. It might summarize the list, but it won't necessarily, deduce the causal link or reorder things logically.
So CAD-T is the solution because it forces the model to think like a human safety investigator would.
It forces structured reasoning.
Ah.
CAD-T is an advanced prompting method where you explicitly tell the LLM to adopt a step-by-step cognitive strategy. So instead of give me the report. Right. Instead of that, you command it to analyze the intermediate steps, check for causality, and then construct a final coherent solution. It mimics how a person would build a case.
So let's look at the actual prompt. How did they force the LLM to impose logic on that jumbled data?
The prompt, which they call P, is highly detailed. It combines a predefined instruction with that sequence of unique events, U, detected by the vision model.
And the instruction is really specific.
Very. It doesn't just ask for a summary. It explicitly demands that the LLM analyze each event, ensure the logical flow, and then compile a very structured report.
With specific fields it has to fill in.
Exactly. It must include the date and time, a descriptive summary of the sequence, the definitive root cause, any observed damage, actions taken by people on site, and most importantly, clear, actionable recommendations.
So when the CV gives it a sequence like goods fall at 10.01.05, followed by forklift lifting goods at 10.01.06.
The CAD prompt basically tells the LLM, hang on, logically this has to be wrong. A lifting action cannot follow the falling action in a root cause sequence.
Right.
And the LLM uses the rules of, physics and operational common sense that are embedded in its training data and reinforced by that prompt to infer that the goods falling must be the consequence, not the precursor.
So it uses its language intelligence to interpret the causal relationship
And reorder the elements into a believable narrative. It corrects those minor temporal flaws from the video processing.
That ability to self-correct, to impose a narrative logic, that feels like the true breakthrough here.
It is.
It means the system is robust enough to handle the noise of the real world. Which brings us to Section 3. Evaluating the quality of these AI reports, and, just as important, their speed.
Yeah, we needed a really rigorous evaluation, so they used a mix of quantitative and qualitative methods.
Let's start with the quantitative. They used cosine similarity and BERT metrics.
They did.
We hear BERT F1 score thrown around a lot. For anyone listening, what does a high score there actually tell us about a safety report?
It tells us about semantic fidelity. It's about meaning. These metrics look way beyond just matching surface-level words. A BERT F1 score compares the meaning and the context of the AI's report against a benchmark report written by a human safety expert. So achieving a score like, say, 0.894 means the AI report's underlying concepts.
Its explanation of the root cause, the actions it identified.
Exactly. All of that is nearly 90% aligned with what a highly trained human would write. It's a measure of conceptual accuracy, which is essential for legal and compliance documents.
And then there was the qualitative check.
Huh.
because a report can be accurate, but it also has to be clear and actionable.
Right. For the qualitative part, they brought in domain professionals from Conway Packaging Services.
The people who actually do this for a living.
The experts. They didn't just look at numbers, they rated the reports on clarity, on coherence, and the overall sort of appropriateness of the language. They were looking for something that felt professional and was immediately useful.
Okay, let's get into the model showdown.
Oh.
Who performed best? The smaller models, the SLMs like Mistral 7B, or the heavyweights like GPT-4o?
Well, in the quantitative accuracy race, we actually had a tie, which was fascinating. Yeah. Mistral 7B, which is a powerful but much smaller model, under 20 billion parameters, it performed incredibly well. It got a BERT F1 score of 0.894 when it was paired with YOLOv11.
And the LLM champion.
That was GPT-3.5-turbo. It also hit a BERT F1 score of 0.894, but when it was paired with the faster R-CNN detection model.
So Mistral 7B proved that you don't necessarily need the absolute biggest, most expensive model for top-tier numerical accuracy.
That's a huge finding.
But that leaves the qualitative winner. Who wrote the best, most human-readable report?
That was GPT-4o, hands down. Despite scoring just a tiny bit lower in those hard quantitative metrics, the expert review concluded that GPT-4o produced the most fluent, the most coherent, and the most precise responses.
So if a safety manager has to present this to a board or an insurer?
The fluency and nuance of GPT-4's language made it the clear, qualitative choice.
This presents a real implementation dilemma for warehouse operators, doesn't it?
It does.
You have to balance the highest measured accuracy against the most readable output. And then you throw the cost factor in. Is the premium for a model like GPT-4o really justifiable when Mistral 7B gives you the same quantitative score?
That's the ultimate real-world question, isn't it? If you're a massive operation under immense legal scrutiny, that qualitative edge from GPT-4 for your high-stakes documents might be worth the cost.
But for a smaller operation?
For a smaller operation, prioritizing cost-effectiveness, maybe even data privacy, the Mistral 7B option is so compelling. It gives you almost identical quantitative accuracy, and you can often self-host it.
Which means you bypass API fees and the latency from external models.
Exactly.
That's a great way to put the trade-off. External API dependency and superior language versus self-hosting with super strong numerical results. Now let's talk speed. In safety, every second counts. How fast is this whole pipeline?
This is where the GPT models really dominated. They processed the data and generated the report much faster than the Llama and Mistral models.
And who was the speed champion?
The efficiency champion was GPT-3.5-turbo. It achieved a minimum total analysis time from the frame being extracted to the final report being ready of just 3.245 seconds.
3 seconds.
Just over 3 seconds.
That's almost instantaneous. I mean,
Yeah.
to have a fully structured report detailing the whole sequence of events, the inferred root cause, just seconds after the goods hit the floor, that completely changes the timeline for response and investigation.
It allows for immediate intervention. Imagine a supervisor getting that report with actionable recommendations while emergency services are still on their way.
The huge latency that plagues safety investigations waiting days, even weeks for manual reports.
It's eliminated. The safety cycle is compressed down to real time.
So if we synthesize all this for someone listening who is thinking about implementing this, what's the recommended final stack?
For detection, you use YOLOv11. Its recall and accuracy are just superior. For the reporting part, the choice depends on your priority. If speed and quantifiable accuracy are paramount for real-time alerts, then GPT 3.5 Turbo is the most efficient. If the goal is producing gold standard, highly coherent documents for compliance, you lean toward GPT-4o.
And the budget option.
And remember, Mistral 7B is a robust, really compelling alternative if your budget or a desire for self-hosting is the main driver.
This whole integrated framework is just a massive leap forward for workplace safety.
It is.
It moves us from reactive reporting to proactive, context-driven analysis, and the results are undeniable. The system gets high alignment with human expert reports, cosine similarity scores up to 0.878.
It's a complete solution that really addresses that critical gap in traditional methods by demanding and generating the full causal context.
But the research doesn't stop here. The researchers themselves point to some fascinating future directions. We focused entirely on visual data, what the system sees.
Right.
But what if the system could also hear and feel the environment?
That's the next logical step. Multimodal data integration. The current work is all video, but integrating audio and sensor readings could dramatically improve accuracy.
How so?
Well, hearing the sudden, sharp clang of metal, or monitoring temperature and vibration data from machinery. It provides redundancy and confirmation that vision alone can't offer.
And finally, the ultimate goal of safety isn't just faster reporting, it's prevention.
Exactly. And that's where the researchers are moving toward incorporating predictive analytics.
Using all this contextual data.
All of it. The full chains of thought from near misses and actual incidents, the system could learn to identify those precursor events.
And alert people to potential hazards before they happen.
Going from automated contextual reporting to automated real-time prevention.
Predicting the accident before it happens, that sounds like a deep dive we'll definitely need to schedule for another day. Thank you for guiding us through this powerful integration of computer vision and chain of thought prompting.
My pleasure.
That's all for this deep dive. We'll catch you next time.